It's all get started at the end of its lifetime. The death of a star, likely our host star, Sun, will swell up into a red giant, expanding out beyond in the orbit of Venus. As it burns through its fuel, it will eventually collapse inside the Sun. The outer layers will be ejected in a shell of gas that will last a few tens of thousands of years before spreading into the vastness of space. The small core, a newly formed white dwarf, will illuminate those layers in a lightning, and this process will be duplicated in stars that have up to 8 times the mass of the Sun. Massive stars, at the end of their evolutionary path, explode into supernovas. The expanding shell of gas forms another type of nebula called a supernova remnant. The Crab Nebula, M1, is a good example. Other types of nebulae include emission nebulae, which are clouds of ionized gas emitting light of various colors, dark nebulae, which are clouds of gas so dense that background light is blocked, and protoplanetary nebulae, which occur when a star starts to shed its outer layers before becoming a planetary nebula. So, in about 5 billion years, when the Sun shucks off its outer layers, it will create a beautiful shell of diffuse gas, known as a planetary nebula. About 10,000 of these short-lived, glowing objects are estimated to exist in the Milky Way, although only about 1,500 have been detected. The unseen rest hide behind interstellar dust. The term planetary nebula is a misnomer. It was coined by William Herschel, who also compiled an astronomical catalog. Herschel had recently discovered the planet Uranus, which has a blue-green tint, and he thought that the new objects resembled the gas giant. The first planetary nebula to be discovered was the Dumbbell Nebula, M27, by Charles Messier in 1764. He eventually added 4 to his catalog of astronomical objects. In 1790, Herschel found NGC 1514, a planetary nebula with a bright central star. He realized that these new objects were made up of gas, or dust, rather than being clusters as thought at the time. Herschel identified 79 objects as planetary nebulae, but only 20 of them truly were, while 13 others that he had classified as other objects turned out to be these gaseous shells. However, with the help of new technology, has captured a number of phenomenal images of planetary nebulae in extreme depth. In doing so, it has revealed the complexities that could occur at the end of the life of the Sun. Where scientists once thought that the gaseous layers came off evenly, images from the Hubble Space Telescope have revealed a wide array of possibilities that could be the fate of our closest star. According to the scientists, for the first time, a magnetar has been found with a wind nebula around it, adding on to the wild nature of these ultra-powerful stellar remnants. The magnetar nebulae are a type of pulsar that has an intense magnetic field around it, making these supernova remnants the most powerful magnets in the universe. Though magnetars, and other pulsars, are around 12 to 15 miles in diameter, they're made of highly condensed neutrons and emit regular bursts of energy in the radio spectrum. There have only been 29 magnetars found till the time, so, granted, the sampling size is small, but the newly discovered magnetar Swift J1834.9-0846 has another unusual feature around it, a so-called wind nebula, where the gases expelled by a supernova are then whipped around to velocities approaching the speed of light by the pulsar at the heart of the former massive star. The observations of the wind nebula were taken by ESA's XMM Newton Observatory. Initially detected by NASA's Swift telescope in 2011, 1834.9-0846 may be associated with the W41 supernova event, putting it around 13,000 light-years away. Given what's known about that supernova, astronomers believe this may be a longer-lasting wind nebula than any spotted before. Further studies could give insight into how these discoveries were made.